Welcome back to the series where we convert worded problems to show you the technique on how to easily convert worded problems to mathematical language or understand them so that you can solve them with ease and at least be able to interpret them. Now, these worded problems, they're very interesting and they're very good at helping to improve your mathematical thinking logic and also to improve your ability to, think the way computers think in terms of algebra. So let's jump into it. So in this particular example, I have decided to just give a final blow to these worded problems and deal with certain, which is if they are worded problems and if we're trying to squeeze out the words, the numbers out of the words, then there are certain words that are mathematical terms, then it's best to just go straight to them and just identify them, right? I didn't do this in a previous video, so I'll use this opportunity to do it. So for example, this is the number 5 that is given, right? But if you look here, you will notice that the word more is equally given, and that is a mathematical term. I will explain why. I will explain how. Now you have the word each. That is not, or that could be considered a mathematical term because that translates to 1, right? And then you have another each. Then you have 3. But you had 4 here. Escape this one. And then you have the word total. This is a mathematical term. And then you have, of course, this other number. Now these are the only relevant numbers or relevant terms, notations in this question that you will use to squeeze out the number and then find the relationship between them. But like I was saying in the previous video, you look at the facts and then you look at the relationship between facts. Okay, but before we talk about that, what are the other terms, right, that you should expect to be used? Probably not be able to exhaust them because they come to mind as I think about this video. What are the other terms that they might use when trying to phrase these mathematical expression into words? Let's talk about that. For example, they use the word more. That word more would more or less be used to indicate that will translate to plus, right? So the more there will translate to plus, and you see how this will come when we talk about it. So more translates to plus the same way that sign there translates to the word addition. Well, mainly add, not really addition, because addition is the operation itself. Inequality translates to the word plus. It equally translates to the word, we said more, add, plus, increase. Increase. Let's do this concurrently with the word minus. That will translate to subtract. Subtract. It will translate to the word remove. Now we had said more. More is not the same thing as more than. That would be left for this comparator. This one here is used as a comparative. So when you say something is greater than, and that thing is equally more than. More than, but of course the unique context for that's the second one there. So you have remove, you have decrease, so to be more words for negative than that. Then you have discount. Yes, discount. Even if it is used mainly in percentages, equally means to subtract. Discount. And then you have other words as well. For example, well, let's not forget the word positive. Positive and negative. Yes, this whole journey of symbology. And then you have the other words, you can discover them on your own as you go. But obviously, if you have words that indicate removal, yeah, that's what you're talking about there. And anything that adds, that's what you're talking about. So all of this word will be used in language art to say plus, or to say minus, or to say greater than. Of course, remember if it's the right hand, then it's greater than. If it's the left hand, it's less than. Okay, now you equally have other signs to be committed to. You have this and you also have this one. All right, this one here would translate to par. So when you hear the word par cent, what you are saying is par, and then you are saying cent. Cent is the same word in century. It's the same word in 5 cents. All right. What it translates to is it simply means 100. It's a Greek word for 100, and then the par there is just the Greek word for divide. All right, and then it will be represented by that line. Obviously, I should actually state this too, that there are other symbols that can indicate some of these things. So for example, you could use this, or you could use this. This is equally divided. Then now, so if someone says 15%, which this is used as a shorthand for percent, what this means is 15 divided by 100. Good. So we can move on. So we have that as divide as well. And this is multiply. or distribute. Well, we want to be careful. Now I'll skip that distribute because it might have give a feeling of sharing. Sharing here is for divide. When you're sharing, you're dividing. Very important concept in fraction. Something connected to this, and also ratio as well. Ratio is tied to this concept a lot because it is all about sharing, right? Okay, so what else do you have here? You have here on the multiplication you have bracket. You have bracket as well. What else do we have? For you could see symbols, you could see words sometimes off and maybe by being used, but I put this by in bracket because it needs a context. All right. But when we say 15% off, most times 15% off would tend to mean, okay, of whatever number they're talking about, you probably would have to multiply with that number. But of course, context is needed in order to figure out, what the by or off is attached to. So you have quotient and then you equally have sum. Yes, we would all have to add this word. Now, these are not symbols. They have symbols for them, but this is not the place and time for symbols for this. For example, we don't talk about this at this grade level. Focus on these ones at least introductory. Now, for quotient is the answer that you get when you divide two numbers, all right? And then sum is the answer itself that you get when you add two numbers. When you add, is the reason why you could equally put the word addition here rather than what add, because add just means plus. And then division maybe for quotient, you could add that, but it's not really relevant. And then quotient will be very much related to the word ratio. And I hope I didn't mention that it is related to divide. Yeah, I did it. Yes, because it gives the impression of things that have divided already, or how two things divide already. Then you equally have product. Product, of course, is the answer you get when you multiply two numbers. I think we've covered some of the common words that will be used when describing or expressing. Don't look out for them. Once you memorize them, it makes it easier for you to interpret this question. Now, using these terminologies, right, we would try to extract the words and the relationship with their qualifiers. For example, we have that there are 5 more girls than boys at a party. What is the number of girls? There are 5 more girls than boys. It's dependent on the boy. So the number of boys is an unknown, but we can always put that unknown as a box. All right. Therefore, 5 more boys would mean 5 plus box. All right. And then for every here, it is said that for every boy given 4 sweets, for each boy was given 4 sweets, which means 1 boy was given 4 sweets. That's what each means, right? If 1 boy was given 4 sweets, 1 was given 4 sweets, then it means 2 boys were given 8 sweets, which is equivalent to 2 times that 4 sweets. Or 3 boys were given 3 sweets, 12 sweets, which is 3 times that 4. In the same vein, box amount of boys who have been given box times 4 sweets. So at this point, we already translate this sentence to be equal to what? 4 box times 4. So now the next part of that sentence says each. We said that is 1 girl was given 3 sweets. But we already know that the specific number for the number of girls would be this. That is a specific number, 5 plus box. And it's a trick, right? So what that would mean is that the number of sweets given to the girls would be, in this particular one here, would be equivalent to 5 plus box times 3. And the logic is the same as the one for the boys. So a total of 162 sweets were given to the children. If you add those two together, sum was given to the children. How many got? Total. The word total would be under sum. Sum, total. It will translate to sum. So it's another word for sum. Good. Now, how many girls were there at the party? All right, so this is easy. Now that we've seen all the terms and we know what is happening, we can now go to the whiteboard. All right, so again, we make our assumptions by starting with the statement, let the number of boys be equal to box. So that would mean that we can now say that it follows now that the number of girls is equal to 5 more. Okay, yeah, there are 5 more. So plus box. All right, and this is because we don't have to say let the number of girls be 5 plus box. We have to make the least amount of assumptions already. All right, and the reason for that is that if you agree with the group of persons to be at the place by 5, let's say for a football game, there is no point asking them again, do we agree to be there before 5 for the game? So if they agree to play for a match to start at 5, then you could just argue from that in that case, you all must be here before 5. That's just a logical progression of thought. So there's that same reasoning. That's the same reasoning here in math. When you make an assumption, you can use that, depend on that to build the next ones that depend on it, that's connected to it. Now, the next thing is how many sweets were given to the boys. All right. We said that the total amount of sweets, for boys would be 4 times box for the same reason that we gave for 4. And the total amount of sweets for girls would be equal to 5 plus box into times. So we don't have to say the times because the bracket implies that it's a multiplication. Okay. Now, the total amount of sweets would be the sum of these two figures here. The sum of these two would be equal to 162. So if you say 4 plus 4 box plus this whole thing here, I'll just put this in bracket again, plus bracket 5 plus box. We have to work that out, which is why I'm going to do that. But sorry for the confusion. If there's any, will be equal to 162. All right, let's go ahead and figure out what's going on here. Now, 5 plus box. And now I said one of the ways to remove this bracket, always remove bracket, is to multiply. If there's a number in front of that box, that number will have to multiply everything in that box, especially when one of them is an unknown. But like we have said in the previous video, that math works because if you have two different distinctive math where you have 5 plus box times 3, and then you have 5 plus box, 5 plus 1 times 3 and 5 plus 1 times 3. If you do 5 times 3 and then 5 times 1 and add them together, you get the same answer as if you add what is inside the box and multiply by 3. And we said that they are both similar and equal. They are not similar, sorry. They are both identical. They are the same. Therefore, you could use any method if the other one does not help you in a particular situation. All right, so yeah, and that's why. Now, if you have like a bracket, to remove this bracket, you always have to multiply. That's why bracket means multiplication. And when there is no bracket, you're assuming that there's a 1 and you're multiplying with the 1 to eliminate the bracket. All right, so this is the reason why the answer to this would be 15 plus 3 box. And we can insert that into our equation to get box plus 15 plus 3 box will be equal to 162. Now, this term here and this term here are very similar. So you could bring them together to get to have something like this. Now, remember, it could be a letter, but once the letters are very similar, you could add them together. And it would be like adding the total number of boxes you have in your house. If they have two different boxes, you have 4 boxes in the sitting area and 3 boxes in the room. How many boxes do you have in the house? Definitely 7 boxes plus 15 is equal to 162. Now, we will deal with this term here. This will be easier to remove before than 7. Let's deal with this, and then we can think about isolating the box and leaving it alone. Because again, the goal is to leave the box alone in one side of the equation. And when everything has been, said and done, what is on the other side of the equation will be equivalent to the answer. Will be the answer that you're looking for. Okay, now how do we do this? We will focus on the number 15 and the sign. We will need to neutralize this sign. The only thing to neutralize this sign is the negative, is the opposite of that sign, which is negative. And the only thing to neutralize this number is what? 15. 15 is the only number that can neutralize it. So we can go negative 15, and that will take out that 15 to knock it out to 0. And then this can be done too, because why? The principle of equality. We had mentioned this principle. of equality. In fairness. Whatever we do on the right side, we must do it on the left side. If we take out 15 from the right side, we have to take out 15 from the left side. If we add 15 to the right side, we have to add 15 to the left side. It's an unbroken rule of not just math, but of reality itself. So you have 7 times box will be equal to 147 if you do this math. And then how do we remove this 7? Of course, only 7 can utilize 7, but then you also have this times here to remove. Division sign can remove this because that is the opposite of multiplication. Division is the opposite of multiplication, or the division sign is the opposite of the multiplication sign. So we're going to use this as a division to remove that, and then 7. Right? You must remove the 2 of them, 7 and the multiplication sign. When you do this, you're going to remove this, and then all you have is the box equal to 147. Would that be the answer? Definitely not. You still have to do the same thing you did to the left side, to the right side as well. And if you do this math, this is what you will have. 7 would enter into 147. We cancel this to give us 7 and multiply to give us 2, sorry. And multiply that to give us 7. Subtract that will give us 0. Bring down 7. Divide again. That will give us 1. Multiply. And multiply will give us 7. Then subtract that will give us 0, which means this is our quotient. And that is the answer. Therefore, the answer for this will be 21. 21. Now, this means that the boys, so you have to now remember the assumption you make. And now, remember, the boys is equal to box. Therefore, this would follow that the number of boys will be equal to 21. Therefore, the girls, number of girls will be equal to which was dependent on the boys and was 5 plus box will be equivalent to 5 plus 21, which is the same thing as 26, and that will give us our answer right here. All right, but don't get excited. You still need to look at the question to make sure that you went through all the steps. You didn't miss a number or make any mistakes step by step. You do this step by step, and that is what your exam requires of you. That you are careful, you're meticulous, and that you can take your time step by step to figure out if your answer is right. This is the foundation of algebra and the foundation for the computer and the phone that has made your life so easy. All right, people, wish you the best in your exams. And if you do have any questions, please put it down below in the comment. And of course, see you in the next video.